Okay. So hi, yeah, this is Coffee Compiler Club. We're here to talk about compilers and language runtimes and typing systems and nil and not the nil and concurrency and anything to do with language implementations. And you're live, you're being recorded. You'll show up on a YouTube feed near you a couple hours after the show ends. Open mic, ask what you want. I reserve the right to moderate, never had to do it. That's it. That's my opening spiel. And anyone have something to start the ball rolling? And I'll do my AA summary. So some months ago, I started down a funny path of doing, well, I was trying to unify Hindley Milner and forward flow typing in a good way. So that was a while ago. I went back and forth between this prototype language I have. So I have two languages now. One of them is just a subset, basically lambda calculus in a C-like syntax, but it's lambda calculus for all intents and purposes. And I kept going back and forth between it and the main code base to try and sort problems out in a simple language with a bunch of test cases. And somewhere along the way, I kept getting hit with things I didn't understand and went back to my prototype, my core language theorem proving language, and beefed up the test cases on it enormously. Like it's all worklist algorithms and any order is valid. And so I changed the worklist order randomly and I try a bunch of different worklist orders, and I kept finding things. And that turned into a week of like sorting out errors have to be monotonically, have to be monotonic. So if you apply multiple errors in the course of running the program, you'll get the same error out independent of worklist order. Because otherwise I can't make a golden rule test that says, hey, this should give me this kind of error, because it gives me one of several flavors according to which order you ran into first.
And
so
the
that
errors that come out of that are an error set, or?
Yeah, basically, yeah. You get an error set out, and in some cases, the error previously the error had been, I found these two things were an error, so I printed internal string and held on to it. Later, I found the same guy, but a new guy on the right were an error, and I printed internal string. But I never found these two were together an error because these two errors prevented me from going out to the edges and getting these two. So then you get a 3 set eventually, right? And then you pretty print however you want to pretty print it, and you say this is the error. So it took me another week to go make errors be monotonically stable. So I get the same error out independent of worklist order. There was another week burned on something else that was stupid. I said, what did I do here this last week? But it also wound down, and suddenly things are like tests are starting to pass again. So it's just been, same story of my life here, stuck in theory hell for the past year. But much more robust testing, and almost all tests are passing, and the ones that aren't are stupidly not passing for stupid things that I think will be done in a week or less. And then maybe the theory will be much more robustly tested, and I can go back to the main code base and try to apply in proper ways. That's my summary update. Yeah, fine.
So did you get the type approximation with the worklist? You generally arrive at the same type independently of the independently of the list order, however you choose to process it. This is stable. This is no matter what, you end up with the same.
The theory says that no matter what, you get a principal type. And you're working a worklist down, and the worklist can do visitation in any order and you get the same type. It's another version of the one-step church roster property. It's the extended version for Hindley Milner that always applies to the monotone and analysis frameworks, the constant propagation kind of stuff. 100%, you always get the same answer when you're done. And I had several variations where I was approaching the edge of an error case, but not quite getting there. And some guy would decide that he would allow a nil or not, and some guy would not. And I had just shortcut the corner and said, chop it off and go to whatever. And that's not monotonic in the end. And you get different answers out. So you have to go back through, and like every little corner case has to be nitpicky correct. But that mostly is done now.
about the errors, how do you choose the most representative, if you will, error that most closely resembles where the error happens? Because the work list.
Right. So there's two questions I heard there. What Aaron said before is correct. I get an error set. So on the Hindley-Milner side of things, if I unify two things that are incompatible, I hang on to them both. So it turns out that I end up with 4 classes of errors that a single error computation. It's actually a standard Hindley-Milner node and whatever, a Hindley-Milner type thing, and it has a slot for, I'm a struct, I have aliases and fields. I'm a function, I have arguments and a return. I'm a base type, which is an element of the lattice. And I have a one-line string, which is I'm some kind of other error, which is typically I'm missing a field in a record, which all I know is I don't have the record in hand. Usually, I just know there ain't, whatever you got ain't got no field in it. So you get these 4 flavors, and inside each flavor, they will do the standard unification. So if I have an error guy because he's got a function and a struct, and I come up with another struct, I'll unify the 2 structs, but leave the error present, leave the function present in the result. So when I get done, I'll have the most general version of a struct that applies, and a most general function, the function that applies, and the most general lattice element applies. But I happen to attempt it at some point to have unified all of these. And then the message just comes out and says something about, pretty print. The other thing that you get out of this is, where does the error message come from? And in my core prototype, I'm not tracking that. And in the main core language, at every point I pick up a constraint, I pick up a program point, which is just like a character offset in the file.
Because the error has to be the most closely resembles as what actually you think it's wrong with the type, because typically you scan the file from one point to another, but in a work list it can pick however it chooses, and these errors have to be you have to pick the most precise error.
Hindley-Milner will already have horrific cross file unifications, because it's not adjacency, it's types got used, they got defined here and used over there, and the conflict is between these 2 points. And if you hit that several different places, which can tell you make a bad type here, he's used here, 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 and here, they all produce different conflicts with this one guy. You do that 2 or 3 times, suddenly you get a mishmash. So in the main AA code base, I do in fact track the program points where I got this constraint from. And then if I start picking up errors, I'll hang on to the constraint. So when I get to the end and I say, hey, you have the following conflicts, I'll have a pile of program points that associate with them.
Do I get the path or just the pile of points? So if I have A calls B, calls C, calls D, and something in A contradicts something in D, and B and C, it just flows through. Do you say A disagrees with D, or do you say A disagrees with D because it flowed through B and C?
It's right now, it's just A and D. The definition point and the use point, and B and C added constraints which caused A and D to have to be unified, but I'll yell at you about A and D. You could argue that I should track all the constraints as I go, and I can do that. I'm not certain if I will get a small enough set that you can ponder it, but maybe. This would be every time I do a unification of 2 guys, I would unify their program points as well, so that when I came to an error, I could come back and say, yeah, I could give you the path. I could do that. In fact, I could argue that if you typically don't have an error, I don't know, if you typically don't have an error program, I wouldn't track these, and I'd just make a second pass to go get you the errors, because it might be expensive to unify, but maybe it's not that expensive to unify program points.
Yeah, I don't know whether carrying around that stuff versus going back and finding it, but I could imagine a moment where it says A contradicts with D, and I'm like, but in what way is A related to D at all?
I know.
Like, what happened here?
Right. I've been there. I've done Elm plenty, and you get these weird conflicts, and typically I sort them out by adding signatures in between in the B and C points. They were just taking standard type inference. So I added a signature. suddenly the conflict's not between A and D, it's between B and D or A and B, right? And you narrow the conflict point. So you just added some signatures and suddenly the conflict became.
Yeah, that's how I've hunted those in the past, is I add a bunch of types until I actually get errors that I can understand.
Yeah, fine. Right. So there's a workaround, but you know, I don't know, you could argue that I can track it. It's not too hard at this point to track. It's just one more thing. They all have to, and because of how I'm testing, they all have to be monotonically resolving to the most general error message. Right. Otherwise you get a different error message according to whatever. So I have to perfectly track in identically the same way the errors, the program points to go with the errors.
And the errors don't just eat the world and you get something out that's like, you cannot use any as a nothing.
Right, exactly. No, they don't. But that's how that's how I can survive having errors that aren't used. Like a classic hidden error, you get two things that unify. Fail to unify, you blow up and you die. First touch, misunification, you throw in assert, you know, or whatever, it blows out and you're dead.
But the problem is that it's scanning from the definition from top to bottom, and that's when you fail to unify, it will point you precisely because it's scanning from top to bottom, and it will give you a good error message. The question was in a work.
Wait, you said
not the best, not the best.
You get a good error message, but you don't. That's my experience with Elm, which was it is pure functional language using Haskell, literally using the Haskell infer. The answer was
yes, that's correct. I agree with this. The
okay.
answer is I agree with this. It's not the best error message.
No, it's like remotely far from each other, like fucking no way. How the hell is this going to blow up?
Yeah, and in my question was, does it will, in my opinion, become more harder in a worklist situation because it picks the truth and the order however it chooses.
Right. So the answer for the forward flow types, which is what every other language on the planet's using, is you have a most general form of the error, is what it comes around to. So I'm going to have a most general form of the error for the Henley-Milner side too, and claim it'll do. It'll find the error in the same kind of a way. I see. You're saying that because of the tree order walking, you get a certain you see a certain order, you get the error. You get the same error every time. It's just not necessarily related to where you are in the tree. The tree found it first, but the tree visited some other points, got to here, and said, "I blow up from here and with fucking something miles away." And what the hell happened? Yeah, and I'll track the program points.
I'm not certain it will be beneficial to track the certain line if you encounter it to somehow be it a worklist, but you have positions in the lines, you can stitch them some.
Yeah, you get a character offset in the file.
Yeah.
So I don't even tell you the line. I'll point out the point and the two points. These 2 points. Here, A defines variable to be whatever. Here, A is used as a whatever. Can't do that. They conflict.
And if you sort it, you will get effectively back the top to bottom.
No. Then the presentation has to be in a general unified way, and the obvious presentation is you would list them in order in the program.
Okay.
But I have to have the most general error just has them all, has all the points you want to talk about. And then how you actually present it. I actually, in AA, I sort the errors by a variety of things that say, this is most likely your root cause. I have a bunch of dependent fails. And it's not the first thing that failed. It's the most obvious thing, like a missing field name or a missing variable name, like you're missing a def. You use the variable, didn't def it. It causes a lot of follow-on. So I claim that was a eager one. There's a couple of others I have that are like higher than other things. Syntax errors, I can't actually tell what the hell this is supposed to be. That'll blow out early. And then there's some later ones where inference fails for whatever reason, but I start with whatever, this was missing, so I don't know what the hell to do with this. So I gave it some junk type because I had to guess. Then I ran forward and it failed to infer properly. I don't want to tell you the inference on the junk type. I want to tell you I started with the junk type.
Not to mention, if you try a parser recovery, if you switch the identifier, and that would be much harder in this situation.
Where
If you
I'm
try,
at is I kind of sort of do partial recovery. Like if you do a mention of a missing field, I claim you typed a field, I'll give it a type and I'll carry forward. If that type's not the type you wanted, it will surely cause a further errors, but I can continue parsing at least.
So how is this going to interact with user space labels that may come from subclass? So if I want to make a HTML string type and say, if you want to add together two HTML strings, great. But if you try to add a regular string to an HTML string, blow up at me.
Well, that's the function lookup. So somewhere in the world, you're calling an add has string plus string. You add a new overload that's HTML plus HTML.
Right. My worry is that it's going to unify them and go, oh, you're adding a SQL string to an HTML string. Well, those are both subclasses of string. Let me unify up to string and use the string add.
Oh, you like an HTML string or an SQL string that's a subclass of a regular string.
Right, so that I can prevent you from doing things like adding your regular strings to HTML strings without going through an escape or a templating or.
Well, I would have said you don't make SQL strings a subclass of string. Right, that sounds like a dangerous plan.
I see.
I don't know. Your subclass of strings are already dangerous. Like Java makes string final for a reason. The subclass of strings dangerous in the sense that, okay, I have two things. Standard subclass rules apply. I have two things. I have capital I integer, capital N number. I add them. I get a capital N number out and I call capital N numbers add on number and number and not integers add on integer and integer. Something like that's going on here is what I just heard you say. Except that, you know, add's not defined for number. So that's sort of nonsensical. I'd claim, yeah, if you subclass string and you add a string and a subclass of a string, you get string add, which is concatenation right now, maybe not what you want.
So if I wanted to tag something and have that tag flow through this system,
you give it a type, it's fine.
You just give it a type and be like, hey, this is a string that came from a user and is not to be trusted.
Yeah, right.
Okay.
Yeah, you can subclass with a tag name. You can how do we do this here? There's another option here. I'm trying to think of the right way to do this. So that what I just said was delegate. For what you're talking about now, string from user, you delegate. So there's another version of this, which is you overload string, user string and user string to do something with it. But if you mix string and user string, the overload resolution guy blows up at you because he says you don't have a most general. Oh no, you've subtyped. Let's see. I think about the right way to do this here. So the rule I was doing.
Yeah, it does seem like subtyping is not really the right answer for my dangerous string.
Yeah, I would say no.
Shouldn't mix with strings.
That's what I would say. I'm trying to think here. The method overload resolution is going to say take the left argument and then look up in its namespace for a version of the right argument. And then you get a most specific fit. And I wanted to blow up at you if I couldn't guarantee that there was always a most specific, like there's no general I accidentally got this overload. There's no ambiguousness. So I wouldn't let you overload somebody. You're trying to overload string add. You want to overload string add with another string, you immediately get four cases. You get string plus string, SQL string plus string, string plus SQL string, SQL plus SQL, or user, whatever you're going to do. And then I'm like half of the opinion that you can't overload the SQL plus SQL unless you do the other two mixed overloads. So immediately you break the argument space into complete four choices, and you've given me a definition for all choices. So it's unambiguous what you mean here. When you mix string and SQL string versus string and SQL plus SQL, I have a definition for them all. And maybe that definition is nothing more than swap the arguments and go again, but you had to write something because immediately you get this mixed mode funny game. And this is only on like operators. If you have standard overloads that you said, call the foo function, you can do whatever you want with arguments there.
Right. I don't know if it's a good idea, but I know that Python will call left add on the thing on the right. And if it returns type error, then it will call write add on the thing on the left.
Oh, I see. So he'll automatically do the,
So it says left gets the first opportunity, right gets the second opportunity, and if they both return type error, then congratulations, you get a type error.
Oh, that's really cool. I didn't realize those semantics. That's pretty cool.
I've heard about this.
I
He
have
did a
yet to
bunch of-
decide whether it's a good idea or not.
Right, yeah, me either.
Yeah.
Right, because it gives you a certain associativity, commutativity, sort of for free.
Well,
Gosh, but-
A
It
plus B
makes-
might
it
not
makes
equal
sense
B
in
plus A.
Python. I mean, it matches everything else in Python in terms of we'll figure out the behavior when we get to runtime.
Well, there's that part too. I'm not talking about that part. That's the performance. I'm talking about what is it? The semantic, is the semantic meaning usefully obvious? Like you can tell what the hell is going on, or is
If you're
it
using Python, that's pretty obvious. Yeah.
that left add is tried before right add?
Yeah, because the Python approach is basically, look, at runtime, you give us stuff and we will try it one way. If that doesn't work, we'll try it another way. And if that doesn't work, we'll try it another way. And if that's too slow, call a C library. It makes perfect sense.
I see. I'd claim that JavaScript does the try it approach, and Python less often does. And they usually make better choices as far as I'm concerned, but not necessarily ones I would make.
But JavaScript
Yeah, I
is
feel like
more
in
like
JavaScript,
every,
you sometimes get confused where you're like, why is the empty dict plus the empty list not the same thing as the empty list plus
Yeah.
the empty dict?
well, you just have to wait 5 more years and they'll add another equal sign to the operator.
Well, there's another empty too. There's more equal signs and there's more empties. Or nils or zeros. I don't know.
Isn't it just null and undefined? Or is there a third nothing that I'm not thinking
Well,
of?
the empty string shows up as a falsy in many contexts. I guess I was claiming falsy versus truthy, right? The empty string is a falsy thing.
Oh, yeah, you can override Tuple on any object and make anything falsy if you want to.
Well, there you go.
Can get confusing in Python.
Right. Yeah, I voted a different route, which is everything is truthy and falsy, and there's no conversion. You just know that it's truthy or falsy. Everything is. Now, is it a better design choice? I don't know.
Is there anything in your system that if treats as false other than nil and false?
I'm sorry. Is there anything in my system that is what?
Your if only
Yep.
checks for nil and false, right?
It only checks for nil. Now, everything can have a nil flavor of it. So integer 0 is the same as nil. Floating point 0 is the same as nil. The nil pointer for pointer to references. The nil function value can also be a nil function pointer code.
So if I make a my awesome collection,
Yeah.
can my awesome collection have a this time it's true, this time it's false, based on whether it's empty or not?
Yeah. You can, or you're asking, can you overload it?
Right, can an
No.
object decide, hey,
No.
I'm a real object, but I'm also,
No, you have a pointer. The pointer has its nil or it's not the nil. When you test my awesome collection, you're testing a pointer for being nil or not. If you want to have a truthy or falsy.
okay, so if I want my awesome collection when empty to be false, I need to make sure that when it's empty, it's nil. And it is the null pointer.
So hang on a second, let me pick up Blackbeard here. I'm sorry, say again, because the obvious thing is you have an is empty call. Or you do size, which is 0 for falsy.
Yeah, I think most of the time you would say if collection name dot is empty.
Yeah,
But
right.
if I just want to say if collection name,
That's testing the collection itself for nil or not the nil. The collection pointer itself, same as in Java or C. No function call has been made. You're doing a bit comparison on the pointer bits.
okay, that seems likely enough to not confuse people.
Well, that was the goal. I didn't say it was the most cleanest optimal, but it was very easy, in my opinion, easy to explain. And there's no question about what it means to be falsy or truthy. It's always the same for everybody, everywhere.
Yes, I'm often surprised how frequently easy and simple go against each other.
Yeah. I find like is empty to be verbose. And I have a lot of places where I use a shorter version of the word size to mean give me the size, which if it's 0 is empty. And in AA, I went for the size is the operator pound sign, like numbers, like the length array is pound. That's the length call in an array. And I'm going to have it be a function over operator overload and work for dictionaries as well. So you want to know how big an array is? You run pound on the dictionary name, pound my collection.
So if I want the pound operator to work on my collection,
Yeah, you can
I just implement underscore pound underscore as one of the functions that operates on my thing.
That's it. And you have a 1 character length check.
Well, I guess it would just be pound underscore because it's not a two operator, it's a single operator.
Prefix calls pound underscore. And it gives you a 1 character length check, which if 0 is false and if non-zero is true, it's how you test for empty collection.
And you're going to have an allow list of symbols that can be overridden in that way.
Yeah, I have an operator list. Yes.
If I want to be like caret % ampersand asterisk
As long as
underscore.
all the characters involved are in my is operator character list, you're good. Same as like Scala does. Here's a list of characters. They can be operators. And the only thing different on an operator is I'll allow you to put the underscores. And as soon as you put the underscores on it, it's now an operator and can appear in the infix, whatever the underscore placement is.
So any symbol that is made entirely of special characters that is either prefixed or suffixed with an underscore is
Or
an
you can be in
operator.
the middle too if you're a 3-way guy. Array assignment is a 3-way guy. There's an array, an index, and a value. It's a 3-way guy.
What's your syntax for that?
Yeah, it
Same as
parses
C?
right now. That's array of index equals length. Let me see here. I should probably put this in then.
That does, so correct me if I'm wrong. I don't know if this is the right discussion, if we're in this discussion or not, but it seems like that is going very much back to sort of like what Aaron was talking about with Python earlier, where if I know what symbols to override, and then it sort of merges it with something like Go, where I sort of can match up and implicitly decide or realize that this interface is implemented just by implementing these methods, sort of like a Haskell something, where, okay, I'm going to do the show trait because I implement show, then this matches. Is that sort of the implicit idea here?
So, right. So the
Because
difference
I think that's
here,
really cool. I think that's really cool.
the difference here is you can add operators or add functions. This operator is just another function call. You add function calls wherever you like. And separately, you can add a name to a type. If the named type is been predefined as a type, like I'm claiming you're a person object or whatever, you must implement the following things or you're not a person object.
Right, yeah. So that's like so that does seem to go, at least the way I understand that, seems a lot like the way that an interface works in Go, where I define 3 methods that every interface named Bob has to implement. And it just so happens that if the compiler detects that I implement those 3 interfaces, then I can be passed as a Bob. It doesn't matter if I'm a Bob or not.
I see. Yeah, for me, you get to choose. Each individual receipt site can choose to take a Bob or take something with those functions.
Okay, got it. Okay.
And it's just purely a tighter constraint.
Yeah, exactly. I think that's probably how Go actually does it. I'm just blanking on the details right now.
Okay, fine.
But I think that's really cool. Yeah.
Oh, good.
Yeah, no, I think that's really, really neat.
So this is like type inference for like
exactly.
things. You have all the fields I need. Okay, they're good.
Then that's exactly. Yeah, exactly. Yeah.
Yeah. Let me add the. So there's the syntax for the length. I guess you probably, like this, array arrow, and you do something. The assignment operator is the one thing I don't have working as much as I'd like for the assignment operator is how L values work. I haven't sorted on that one. If I want to do like there's a theory that says if you do array and index, that's an L value, and I can pass it around as an L value independently of anything else, and then later you can assign with it. And I haven't like decided I want to go there yet or not go there yet. That's actually, it's kind of an interesting question. So this is the version of with L values, which is not, I think, sorting on it. So you get an operator that looks like this. And you get another operator like this for a read. And you get an operator like this. Watch my equals for meta versus not the meta. Actually, this for assignment.
If the symbol has an equal sign in it, I would force people to put that in parentheses.
You mean in my very first guy where I see array assignment and someone says x confix n of y in a bracket of n equals y. Yeah, like that in assignment. I previously, and I went back and forth and I yanked it. I used curlies as the uniform way to talk about operators when you're talking about the meta symbol for the operator. So not round, but curly. And no spaces allowed. It was like this. The goal being is that you're making an operator name. It has no other legal syntax to do it this way, but it is definitely a function you're talking about. You're talking about an operator, you're talking about a function. So yeah, I forced you to use a function syntax. And then I decided that it wasn't necessary. So in the interest of minimality, I yanked it. And let me put both of them there side by side.
Even though you've got two equal signs in the same statement?
Well, the first guy, this equals, I don't see, how do I color this in Google? I want to do a text thing. What you're confused here is the symbol construction versus the syntax for an assignment, right? Normal text, Arial title, no, like any coloring? Can I color text? Text color. So yeah, here we go. Okay, so the stuff in blue is a single lexeme, a single token that represents the name of an operator of bracket equals, that's the whole operator, with two positional arguments, a leading and a trailing positional argument. So as soon as you put a space, the lexeme ends, the token ends. Now I have an equal sign. That means I'm assigning this. This is a token. I'm assigning it as a variable. It's a standard variable in the variable syntax. It has a funny spelling. The spelling is underscore bracket equals bracket. That's the spelling of a variable name. It's a variable, standard variable name. Is equal to, and then something, which happens to be a function of two arguments. Okay, as soon as I see that it's a function of two arguments and you're using underscores, the parser interprets you as an operator. And you can call it like a function by leaving the underscores in, and you can call it like an operator by putting the underscores out. So a valid function call syntax is something here for an L value and some value I'm putting in. That's an assignment here. We go get rid of the color on that because that's not part of what I intended here. And I guess I got rid of the bold as well. Like that's a call. And then there's the Infix version of it, where he's going to capitalize my L's, which is probably a bad choice for an L value. Let me spell out L value. And I'll let Google 8 capitalize. So that's half of an L value. That's the tail half of an L value call as an infix, right? And you can totally, do two calls here. So I could say array of square bracket of index of right bracket equals 1, 2, 3. That's my standard array. But the first two, array and index, with the square bracket in the middle becomes an L value. And then you call the second guy with an L value and 1, 2, 3. So that becomes two function calls for an assignment, but the first one produces an L value. And then, of course, in the case of arrays, you guarantee inline everything and all disappears, becomes fast and blah, blah, blah.
So in this case, ARY is mutable, but IDX and 1, 2, 3 are immutable.
Yeah, now, however you implement these is up to your implementation. So there's a primitive version for arrays, which does just what you said, but you make a dictionary here. You can implement your own dictionary, and now you can have your own Lvalue constructor, which just takes a pair and a key. So replace array and index with dict and key, and you get the same exact semantics, same exact thing. And you get Lvalue is just a pair of dict and key, and now you can either read the dict key combo or you can assign to it if you add a value. So that's my current theory on Lvalues, and I don't have this implemented. I've just sorted it out that it could be implemented this way. And that would give me a Python-esque, but it gives me an Lvalue. What it really gives me an Lvalue. And
But I
Lvalues
assume
are
at definition,
facts.
you have to tag the thing that you want to take in as an Lvalue so that you can actually mutate the thing at that.
The array as a variable, the variable for array may be mutable or not, but you're talking about the contents of the structure. So standard rules for structure contents and arrays is they're mutable unless you say otherwise, and you have to initialize them, which for arrays is tricky. So standardly, those would be mutable.
So we spent a fair bit of time on this particular problem, and we entered,
Mutability or Lvalues?
well, specifically the temporal existence of an Lvalue as an independent concept during compilation.
Yeah,
versus,
can I pass them around? Can I hang on to them for a long time? Yeah.
Well, that's the runtime side. So yes. So we didn't want to force the runtime realization of the Lvalue unless the developer forced us to, right?
Right.
Because there's a cost.
Yeah.
Even if it's on the stack, even whatever, there's still a cost, right?
Oh yeah.
So what we did is we actually introduced at compile time, there's a concept of an assignable, so an Lvalue. And then all of the supported Lvalues have all the compile time supported Lvalues have a representation there. But then at runtime, anything can provide an Lvalue by implementing what's called the var, the variable.
Yeah.
Basically, there's an interface for variable that extends the interface for reference. And so it becomes, so reference, think of that reference as an R value, and think of variable as an L value. So all L values are R values, but not vice versa. And so I can't remember the name, but the array implementation is based on an interface, I think it's uniformed indexed. Yes, which has, so it has three methods at runtime. One is get element by index. One is set element index value. And then one is called element at, which returns the var of the element. So at runtime, you can actually explicitly get the reference of the pointer, if you will, for the cell.
So now the question becomes, how much overhead does it cost you to maintain the L values, and is it a useful concept? Like in Land of C, L values happen all the time. People take address of whatever and then pass it around forever. In the land of a garbage collected language, as soon as you take the address of an interior value and pass it around, life got complicated.
Correct. That is correct. So the generally speaking, if just Joe developer implements this on something, it's going to be as heavy as any object.
Okay,
but
that was kind of where I was headed for too.
But the goal is to be lighter than that for types that are understood intrinsically by the runtime, like an array.
So the land of HotSpot makes array addresses in the middle because it does, pointer strength reduction.
Mm-hmm.
And there the lifetime is known to be just this compiled method. And every time I cross a safe point, I record the base of the array and the register, which is known to be at an offset from this base over there. And so the garbage collector at runtime reads the metadata, subtracts two to an offset, does his shuffle with pointers, and then re-adds the offset. Right. So it added a complicated thing. It added an extra tag in the metadata. I actually step for the garbage collector to go through. But I don't have to actually make an object and manifest it because I've limited the lifetime. But if I was to let the object that L value escape into the general heap, I think I have to make an object out of it.
Yes, yeah. For some definition of the word object, yeah.
Yeah, right. Yeah. You can make all kind of fun shortcuts, all kind of cheaty shit about it, but still there's like
Right.
the two things are kept together somehow in a memory location. They took up a memory thing. And it wasn't.
Yeah, it has to be a
just base
combination of a
array.
pointer and an ID within that structure.
And yes, an ID with yes, and
Whether
whatever
that's
that
an
ID
index
is.
into an array or the name of a struct piece or whatever.
Yeah,
It's
your key
some pointer
is,
plus some offsetty thing.
yeah, right.
Well,
Key for dictionary is the key.
that's the initial implementation. And then, of course, you may be able to garbage collect the entire array minus whichever things have escaped. So it becomes dramatically more complicated if you're trying to optimize for space as well.
Yeah, I mean,
So
for
If
me,
you
I
look at the
just,
syntax that I put at the end of that, would
sorry?
those two things be considered kind of equivalent?
what are you talking about for syntax? Syntax is best done for me looking at it on the screen. I'm looking at the middle of the code block here. We got L values.
So I highlighted something at the end of the code block.
Oh yeah, right. You want
If
to
I call a function that wants to redefine A for me, I
in the
can
current-
either say A equals f of A, or in theory, I could say f of
yeah.
L value A.
Yeah, and so I don't have the syntax for the address of, but I can do that with an L value. That is, say all my variables are in displays, which are frames, stack frames. Every stack frame display is semantically a standard struct. Happens to be stack allocated, but it's a struct. And because I do full closures, you already have side effects. You can get the same effect by making a function that refers to A and does something with it, including assigning it. A is in your scope. You can write a function just assigns to it. So taking the address of it is same exact thing. That's to say, you wrote this, I'm going to add you another one here, where you said f is defined to be, a little f, defined to be a function which does whatever it does for arguments, but the body, somewhere in the middle, says A is equal to, it does a redefinition of A. And A is something previously above. Let me put a definition for A is colon equal to, equal 5, whatever. Somewhere in the earlier in life, you defined A in some scope. You can make a function which just talks about A directly. You need the address of, which I can completely equivalently make a little setter function on the spot right there that just takes the argument you're going to assign to it and captures the A. And then when you later actually want to go set A, you take this bogus function for setting A, and I could call it A if you like, and then it has an assignment overload operator, and it calls the assignment function up, writes the guide.
So conceptually, when we say A equals 1, 2, 3, it's the same as saying ampersand A dot set 1, 2, 3.
Yeah, except they don't typically have a set. I actually do. I don't have setters and getters. I mean, for any of this stuff, I actually do the updates directly. I'm not.
Right.
I don't.
Well, we don't have fields, so.
Yeah. Okay. Yeah. Right. Fine. I have fields, and they're updated directly. You don't have fields. You have, I don't know what the hell you call them. You get something else, but they all have setters and getters that hold their state. But properties, right?
So if I call f of L value of A, I can redefine A inside of that function, and someone who uses A after making that call will see something different.
Yeah.
It potentially points to an entirely new object in place in memory than it did before.
Sure.
If A is mutable, so I wrote A is colon equal 345. A is mutable. You mutated it. Okay. Just like you write a C program. I said A is equal to something. I call F. In the guts of F, he whacks A. I come back from F. A is whacked.
So should I allow you to call a function that takes an L value with a not yet defined symbol?
Oh, no. I have to have a definition for the symbol in order to get an L value. So can't be done.
Because so what I'm thinking of is Lisp's def function.
Which
that takes a symbol that isn't defined before you call def and is defined after you call def.
No, I don't have that. You have to define it. The parser is intimately involved in defining symbols. Some text has to occur somewhere to define a symbol. I'm not letting you create a symbol, new, fresh symbol, never before seen at runtime. All symbols are known at least by the parser. If you want to make a new object at runtime, you're welcome to, but it won't be a symbol. And maybe make sure we be careful. We mean the same thing when we say symbol. Right. So you had address of A as the definition of a function. And I would say, I don't support that syntax. But if I were to say I have syntax which says I meant to take the L value of A, the argument, you could define your def, but when you called the def, you only could pass it symbols. Like you defined a function called def. Now use it. You have to have, now a name has to exist as the argument. Right? Put your comment there. Yeah. Now that is syntactically incorrect because you haven't defined name. So define name before you call the function def. There's your symbol for name.
Right,
Def
that's
just
my
takes-
question is, do you need that constraint, or can the fact that,
No, you can't call def takes a pointer to a symbol, pointer to a prior thing. So the prior thing has to exist before, God damn it, auto whatever hell. You know, cat-like typing there, right? So in order to call def, like I can define def, I don't have this syntax what you wrote. I could have it. To define it, it would be it takes a pointer to something, an L value. Okay, great. Give me an L value. I can auto L value local symbols. When you call it, you got to give me a symbol. That's your L value. So that's not creating a new symbol from whole cloth. That's simply updating a symbol by reference. I claim I could do this. I'm not certain it's a good idea. Maybe it is. So the guy writing Anonymous Manatee, I don't know if you know who you are. You said build L value, X equals array of index. That is not build an L value. That is read an L value. Because that produces a value.
Well, this is an alternate syntax. So this is what I'm thinking.
Oh,
of
I
from-
see. Okay.
So so the idea is like in C, I mean, you don't have this weird syntax where you have unpaired braces.
Yes. I understand the unpaired brace weirdness. No one else complained about it. So congrats to you for complaining about it.
So when you have a paired braces, you get an L value.
But then you have to put in, yeah, but you have to have a special symbol for reading.
Right, and then yeah, so like C has this thing where if you read from an L value, it just magically converts to an R value.
Right. And right. And I want some syntax to put in the semantic equivalent of a function call, which happens to be reading from the L value. That's the reason I broke it up the way I did. And it looks weird. That's why I said I'm not convinced I like it. It looks weird.
Does it work if you have like a single L value that's just an ISO, like if you have a variable and you take its address to get an L value,
Right.
then what syntax do you use to read from it?
Oh, now that I have an L value in hand that happens to be from a local scoped variable, I haven't thought that one through because I haven't had to look at this because I wasn't sorting it. It would be in the land of forth, you take addresses with the @ sign and you read with the dot and you set with the bang with the exclamation. The closest I can think of that has the same semantic meaning here. So dot is a funny version, but I could claim dot is a reader of an L value. It needs something to read an L value. Yeah, I would need some syntax. I don't want to do auto conversions of L values used in an R value position. I would want some syntax.
Right,
yeah,
so-
if it was up to me, I would both say in the definition of the function, you have to put an ampersand before it to say this is an L value. And in the function call, you should have to put an ampersand before it to say I'm passing it in as an L value.
Oh, I see. For me, I was claiming that the ampersand give you syntactic sugar, which says the parser is going to automatically L valueize your argument. That's what I was reading that as. So we have a little semantically different there. Seeing an ampersand triggers a semantic sugar at the use site of def, whatever you're calling with a def. the parser does something different. He expects an R valued variable name, and he will convert it to an L value for you. That's different. If instead you say, I need to do it at the call site and say, I have to take address of name to get an L value, which is totally fine. You don't need the ampersand on def. He just takes an argument. It's untyped. You can declare it to be an L value by putting a type argument on it. It says it's an L value, but if you don't do that, he'll infer it as an L value. He knows it's an L value. It's fine. He does L value things with it. So I claim the ampersand on the def call is not necessary. It will be inferred as an L value. And standardly in throughout AA, if you want to type it as an L value, you'd put after the name of the variable, or the argument, you put a colon and a type syntax that says this is an L value. That would be, you know, the alternate version for def would be, assuming I have a type called L value, that would be the alternate version for def. And it's not necessary because it should be inferred. And the first version for me was implying the parser will do something different. He'll automatically L valueize. Same as I was doing with lazy to do and or. It's a very similar kind of game here. Let me go down where I'm going to go way to the bottom because it's different enough. But it's a hint to the parser to say you're going to parse this function differently.
I have a funny story this week about and or.
Uh-oh.
Speaking of compiler bugs.
Yeah.
So I did an optimization probably 5 years ago when I wrote it. The and or both go through the same AST node code generation. And if I identify something as const on the left side, there's an optimization for that. But as a byproduct, one of the optimizations that gets applied is if the result is going into a variable, instead of computing the value and then transferring it to the variable, I actually compute it directly into the variable. So
Sounds like the same to me.
So yes, it does. That's the mistake I made. So so I have some expression A and some expression B. So instead of, so I basically, the first thing is a move from A into the result. And then the computation with B is done against the result location as opposed to a temporary location. And the side effect is that if B throws an exception, the result value can be changed, even though the expression itself, the overall expression, didn't complete. So yes, that that was a hard one to track down.
Gotcha. Yeah. Oh well. I think I'm not going to hit that one. That one's not. I have a different implementation style. Expressions get executed completely before any assignment per se happens, and so you won't get a modification if you throw. But that's just an artifact of where I'm at.
Mm-hmm. Yeah, that's normally how we would do it. This was just an optimization. This was an if that came before the normal code generation.
Okay, somebody wrote, why should I need this? Name colon equals nil. Why should I need this? What's the question?
My argument was, I think that if something has not yet been defined at the time that I reach the call to def, but what I'm passing in is ampersand name or address of or L value of
name
or
doesn't
whatever.
Exist in any scope.
Why can't I use this as my way to define that name?
Yeah. So
and I know that I've passed an undefined in. So you look at that and say, let me go look at the type of this argument. I'm defining a whatever that type is.
Let me give you an alternate, and I'll argue against it here. So here's an alternate version. The other one is pass in the L value directly. And I don't like things that create new symbols I have one way to create a new symbol. And that is you do a symbol name equals or colon equals one of the assignment operators. That's the only way to get the symbol. If you use a symbol, he looks it up in the current scope. So in your case, def of address name, he will look up name in the current scope and all nested scopes. And if name is ever anywhere defined, that's the name you passed in without creating a new local temp.
You don't like it because I have trouble telling whether I've grabbed it from some other scope or whether I've defined a new thing.
Yes, yes.
I don't know if I've redefined something somewhere else.
Yes, it's more difficult to say I'm getting exactly the local guy or making a new guy on the spot or not. And so my theory is no creation of names unless you said name equals splat something. Everything else is referring to a prior variable or blowing up the variable doesn't exist. Yeah, I confused the Google later. Oh, he added oh, I see, fine. I tabbed away from the doc. Somebody added a few lines. I tabbed back, it had page break. I had a completely blank page. Like I tabbed away, there was stuff. I tabbed back, there's no stuff. Fine.
Yeah. I thought someone cut it.
Does the person who deleted it have to hit undo, or can anyone hit undo?
No, nothing got deleted. Somebody added lines.
Yeah.
Things scroll. I'm on this
I
point.
see.
It all scrolled off the bottom. I have a blank page.
Yeah.
I was like, what? Where'd
Too
all
much
the stuff
timestamps.
go?
Too much timestamp. Someone added too much timestamp.
Yeah, a bunch of timestamps added. That's fine. I'll clean it up when we're done, or somebody else who added them can clean them up. I don't know. I don't care. Yes, here it goes. There's
Now it's better.
new blank line got added. I got scrolled again.
So at the
Strauss-Kahn
moment,
syntax. Oh, this
You're
is
not planning any syntax for how to get the L value because you don't have get an L value of this symbol yet.
I'm sorry, I have syntax for getting an L value. I heard you say I don't. I have syntax.
If I have an X and I want an L value that points to X,
Oh,
how do I get my L value that's like, this is X dot B? Save that as something else.
oh, for arrays, I have it defined. You're right. For structs, I don't have it defined. I'd probably do exactly what you said and do the address sign. I mean, we just principle of least surprise to all you C programmers. You take address.
Well, I go back and forth between asterisk and ampersand.
Well,
But I think you confuse people with those going in different directions.
No, I would use the fourth @ sign or the C ampersand before I'd use asterisk. Asterisk is dereferencing an L value. That's the C syntax for saying, given an L value, read it.
But that seems unnecessary. If I have
It's
an L
like-
value, I would think
it's
that I
like-
could just say L value dot, I don't know,
Well, that's the
unpack
question.
or whatever.
What's the syntax for getting the contents of an L value? Asterisk L value or L value dot?
Yeah, one, it's derivation and integration. One is the -1 of the other. The F minus 1.
You mean
Inverse.
the address of and the pointer? Yeah, they're inverse
Right.
operators. Yes, yes.
Even though it's not really an address. Like a
It could-
garbage
it could-
collector
it
could
could be
totally
an
move
address-
something. It just
it
needs
could
to
be an
go find
address
and fix
object.
all the L values.
It can be an address object.
Yeah, okay.
Like everything that's real can be virtualized. I mean, that's, so yes, it's an address.
Yeah, I'm with Cameron here. It's an address.
It's just we redefine address for the language. We don't have an address object, by the way, just to be clear.
Right.
So,
And I don't either, and I don't expect to, but if you take an L value in the middle of an object, I'm very much likely to have some kind of more complicated structure to support that notion, at least to honor the garbage collector.
right, but you could still, for runtime, for
I can have a
performance,
fat pointer.
you can
pass
still
around.
treat it. You can still treat it as an address. Like, in other words, you may maintain the actual address, so you don't have to calculate it if it's some variable length thing or whatever.
Yeah, if I have the right metadata so the garbage collector doesn't get confused.
Right.
You get conservative collector, nothing moves, easy. You get pinning, nothing moves, easy, except it's not easy for the garbage collector to pin, but okay, fine. But yeah, there are all kind of ways to optimize, but the semantic meaning is the same. It's an L value. You can read it, you can write it.
So if I want to append to an array,
Death.
or I'll say a vector because I want something that I can actually resize that potentially allocates memory.
Yes. So as soon as you said vector, it's all good. It's just an array list, a Java array list or a standard CLib vector. Yeah, it's a fixed.
So do I
size
just
array.
say a dot append v, or do I say a equals a dot append v?
No, you call the normal rules. You just call the append function. There's no assignment here because the vector is not itself changing. The underlying array holding bits has more things getting added into it. Now, if you want to add syntax that allows an append by doing like a plus equals and you do an operator overload, so you do. Like commonly I've used redoubling sized arrays, array lists, where you overloaded the square bracket operator to do a lookup in an element. The length operator is overloaded to do the current length that happens to be, and the lookup operator is overloaded to give you the one indirection to the, delegate it to an array, pull you the array element out. Less commonly, I've added the plus equals to append to an array. That syntax worked kind of, but it's got at the edge of where it was obvious what you meant and intended, and you didn't do it by mistake, and was commonly like push or add is pretty short. So I had an array thingy and I said array list and I said dot add element or dot push element. I'm faking a stack, so I had push and pop, whatever. Sometimes I did plus equals, wasn't very often. Does make array list down at the bottom here, because I think that's a good, all kind of stuff here. Oh, block template for copies. I see. I'm going to grab somebody's trying to make my life easier. It's going to make my life harder. Did a copy? Ah, I did. Okay. Let's see what we got here. You want to find a vector object, which would be a function which makes an object, or don't give me this damn thing, which has somewhere in the world an array, and somewhere in the world it has a lookup operator, which is this guy, which I don't have the right syntax for, which is a function which takes self, which I want to have a dot here, and an index, and gives me the array at the index as the return value. So there's a version of here's vector as like a class vector from Java. I would say new vec. You make a new vec, however you get it. You call a function. Well, that gives you a vector, a new vector that's empty, never before seen. The vector itself is just a struct that's got an array that's internal only, no one sees it, and an exported function. I don't have the export syntax in there for an array lookup, but it needs a push operator. Let me go add a push in here. And you wanted a plus equals. Again, it takes a dot for the first argument, and it takes an element for the second argument, and it makes a function that does the array at length equals e, and I'm not showing the resizing. So it didn't say there's a length in here, but there's totally a length in here. There's a length operator, which is this, which is a function which does what dot and returns me the length field. So roughly speaking, I just wrote the entire useful bits of array list. The outermost function is just there to make a new struct that has all the array list fields in it. The array list fields in question include lookup, plus equals, length, and I don't have syntax in there for hiding array and lane, but I'd hide array and lane. The obvious way to hide them for me is to put an underscore in it without it triggering the operator syntax and declare those are private fields. So I'll make that syntax. And let me do some line breakage here to make life a little easier. I need to go to robot monotonic here. No. Someone decided they're giving me an L value. That's not an L value. What are you talking about?
What is the thing that is returned when you do array at index?
The element of the array.
So if I put that on the left side of a definition, is that going to be redefining the thing at that spot in the array, or redefining the array?
After my vec definition down below, add what you're trying to do, because I'm not following, and I'm trying to get the text turned into roboto here, or however the frick it goes. Roboto mono. There we go. That's a little better. I'm probably going to do this to claim private, but I haven't decided this is the right way to say you're private or you're not. Length. No, index. Index is not private. Index is a variable. That's right. Len is private here.
I think it will be useful in each line define the operator, how in a comment how you should be using it.
Yeah, yeah. Okay.
Yeah.
So vec takes no arguments in your little code you're writing below. So get rid of the dot, dot, dot. It just takes no arguments. That makes a new empty vector. And you say vec at index equals 5. Yeah. Oh, you want to do an assignment at a particular index. Okay, so you have to have a new operator. So the new operator is the assignment equals operator, which I haven't gotten here, but I'll just add it right now. Equals bam is equal to, takes a dot, takes n, takes an L, it returns you the array at index is colon equals E. It's going to return you E. There you go. This is update vec of index with E. So that's your assignment at a particular element. I'm missing like range checks and shit like that aren't happening here. Yeah, and your use
So
case.
Cliff, I like that, but it looks like yeah, it looks a little weird. Looks a little.
The syntax looks somewhat cryptic, but it's pretty condensed. If you're used to it, how
I've been
much
staring
more
at
do
it
you
for a
need to
while.
define it?
And we picked a class to implement which has a lot of operators, and operators have a funny notion, have a funny syntax. So that's part of the confusion of what goes on there.
I was going to say, if you replace _ARY with dot, you've got a self-referential type system and you're done.
Well, this is code, not types, but I can totally type this code. I'm sorry, where are you saying?
I'm saying you could implement array the same way. Yeah.
Oh, implement arrays themselves. No, I need a primitive. I have to bottom out at something. You're like, hey, I'm going to bottom out. I'm going to bottom out some primitive. I'm going to tell you what the primitive bottom out is. You're like, I'm going to pick a bottom out location, not tell you where I bottom out at, and I'm going to be self-referential down the line. Which, that's your call. This is my call. I've said arrays themselves are bottoming out.
I'm just teasing.
Yeah, fine. Well, it's not far off though. That was the goal,
Yep,
was to get a pretty straightforward looking thing. I don't have the resize in there for the vec update. Needs to happen. But that would just be the obvious, hey, length is, hits the end of the array length, then replace array with a copied version of array that's bigger and all that kind of shit.
Should be plus concat to vectors.
No, wait, plus this is a vector definition. Is that what you mean by vectors? And I can do a plus. But no,
Concat to vectors.
Plus mean?
Yeah.
What does plus mean on an array list? You got an array list, Java array list. What's plus mean?
So I think what he's saying is you have array plus element, show us array plus array, or vector plus vector.
Oh, you want to add two vectors?
Yeah.
Oh,
so that's more an overloading thing. You don't need a new operator, do you?
Well, it's not a new operator. It would be the plus operator picking up a new overload.
Exactly. That's what I meant. Sorry.
Yeah, I could do that. But I'm going to make a reference to a system.array copy variant that I don't have implemented or anything. So a lot of
Did I get that? Did I understand what you were
Yeah,
asking? Okay.
Yeah.
Okay.
I just want to point out that in the vector code, the braces are matched. They aren't mismatched like they were.
Am I missing a brace? Oh, I am. You're right. You're correct.
No,
Thank you.
the operators. The operators have matching braces. You don't have single brace operator like you had the
For L values? Yes. These
So
operators.
Alan likes this better.
Yeah.
Oh, I see. Yeah, right. The L value ones make sense semantically. They flow well. They fit the parsor. They have unbalanced braces. They're weird looking. I don't necessarily, that's why I'm like, squint. But I'm kind of, I've always been rolling along with the language as this is what sounded like the mathematics and what everything else flows with. So those L values flow correctly with everything else. So here I need an append, which is just the array copy thing, which, you know, I'll claim is array is, you know, array.clone followed by, I'm all cheating this here, array is equal to actually .clone and call it, you know, is one argument to sys dot, you know, array copy or whatever, probably array.copy. The left guy at offset 0 and the right guy at offset his 0 at his offset is pound array, something like this. I don't have it right here. Oh, I see. I have array already. Hang on. This is what I need to do. Clone you. I need to say I'm copying. I already have the left. I'm going to claim, I want to start at the lengthy array, copy array, something like this. You know, I don't claim that's a right syntax, or I don't have the meaning correct for everybody.
Yeah.
But there's clearly a way to implement this. And you know, I'm not doing the obvious shortcut where the left-hand array has space to eat the right-hand array, and you should actually copy into it without cloning it first as a larger size. I didn't do the clone as a larger size, actually. So that would be, you know, length of array, literally plus now the length of vec.array. There, I got a bad line break because Google doesn't like things. Oh, yeah, somebody fixed my spacing. Something like that is going on there.
So when I call vec at idx equals 5.
Vec of square bracket. Oops, there's a scroll happened on me. It was weird. Sorry, you mean vec at index equals 5. You're highlighted the line.
Yes, I've highlighted a line.
Yeah.
Can
right.
that line change the definition of V?
No. V is a variable defined one line above you, and there's no L value going on with V. V is not being changed. The contents that V points to are being changed. You think of V as a Java object. It's literally, you're not changing a Java object there. And the square bracket index colon equals 5, that's just a function call. It's got a little different layout of where the arguments land, but it's just a function call. So you have a 3-argument function. Standard Java rules apply, standard C rules apply. Since there's no address or operator or references going on, and no references or ampersands, it's passed by value. Sorry, passed by reference.
So just a thought, Cliff, since you record this, you may actually want to share your browser screen so that it captures the all the editing going on that you're talking about, because I can imagine someone listening to this won't be able to follow it very easily.
Oh.
Just thinking.
Yeah, right. You're talking about watching
reference.
the document evolve over time in parallel to the video.
Yep.
Yeah, I'd have to parallel record the browser screen.
That will complicate the things.
Complicated recording, that's for sure. I probably have to go ask if Zoom probably can't do that. I think Camtasia or something does that.
Well, I'm saying if you did a screen share of your browser.
Oh, I could screen share the browser right now and watch people edit it.
Right.
I'm
saying while it's kind of going interactive like that, share.
Yeah, right. It quit being interactive now. That's a good answer. I could screen share the browser window. Here, let's go test now.
So I don't have, the vec definition doesn't have spaces on the first 2.
The vec definition, first 2 what?
The first 2 lines of the definition of vec.
Because
those have alphanumerics in there is the thing that prevents them from being symbols.
Yeah. I am toying with the concept of underscore meaning a private variable. So if I want to hide array in Java, I would say private array, private val array, right? In C, I would have to say, I think private or section. This section of variables are private. So, underscore is reasonable in my head to mean it's a private variable. It's not an operator because it doesn't have only operator symbols.
So that is not the private variable plus equals underscore.
Correct.
Because it doesn't have a character. It doesn't have an alphanumeric.
It doesn't have an alphanumeric. So and somehow it lost the bold on the
So
underscore.
anything that starts with an underscore and contains an alphanumeric is a private variable, and anything that starts with an underscore and does not contain an alphanumeric is an operator.
No.
I would just like to mention that you've already used underscore as a pretty serious symbol, but in Unix, a dot indicates hidden.
Right.
But he's using
Oh.
dot for this.
Yeah, I'm coming around. Yeah, that's not a bad answer though. I hear you. I have
Oh,
to
that if I say dot ARY, that's the ARI field.
Yeah, if it's part of the name. Okay, so if it's part of the name, then you have to put dots in throughout the text, the program text. If it's not part of the name, but it's just a one character indicator of being private, then it's kind of a weird syntax, but maybe it's not out of the world. So this would be literally dot array and get rid of the underscore here, with the goal being the dot's just a one character, it's private. And I hear you. It's the Linux file system naming approach.
So if I am outside of vec and I make an instance of vec and I say vec.ary.
Yeah, he would blow up at you and say no such variable or whatever, no such field ARY. That's the purpose of private. If you said, let me come down here. If you added a guide on here, v.ary, no such field. It's as if the ARY field doesn't exist for you.
And
That seems
if I'm
reasonable.
local to the vec object and I want to mutate,
I'm sorry, say again?
if I'm in the vec object and I want to mutate ARY,
Yes, you just mutate it away. It is visible for you as a standard rewritable field. Actually, I need to make it rewritable. So here's a those have to be that way.
okay, so if I have syntax like this, and I say the array is private, but the length is public.
Yeah. And now you can mutate the array and do the length and like all shit.
If I want to mutate the length within one of the functions that I've just defined, I say dot len, and if I want to modify.
No. However you come up with the name of the function. I did length plus plus. I'll highlight length plus plus. Yeah, anonymous Python's there. That's probably me. Length plus plus. That's a side effect to the length field.
That's there simply because it's in scope, because it was defined in a nested fashion.
Yeah.
What if this function is defined somewhere else? And I want to say underscore plus equals equals and just insert a function in there of some function that was defined somewhere else.
So the function that's defined somewhere else doesn't have length and scope. So you have to pass in length as a L value, which we've discussed before, and I don't have implemented. I'm not sure I want to, but maybe if I did, you could pass in L value, or you pass in a function which mutates length. Kind of they're semantically equivalent, and kind of the implementation is almost going to be equivalent as well. Either you know about an L value and you're handed an L value and you mutate it, or I hand you a function that says set new length or set length new, and then you call it wherever you want to set the length. How would you do this in Java if you wanted the plus equals operator to side effect length, but you're going to call some other function to do the plus equals because it's dictionary add and it's complicated to insert in the dictionary. And the dictionary code, once he successfully, it's a concurrent hash map, he's trying to insert, he has all kind of racing things going on. Somewhere there in the complicated loop, he realizes he hits the point of the linearization point where he successfully added the element. Now he wants to update the length. So it's far, far removed from where this code is, doing something horrific to make it happen. You have to pass him a cookie that says update the length. One of the cookies is an L value for length. One of the cookies is a function which happens to be in scope here and is executed over there to update the length.
Okay, I think that makes sense.
Okay, And I'm back to putting underscores to claim I like this a little better than dot, but I'm not settled left or right on it yet. And someone's happily, like, I have to write a syntax colorizer at some point.
Yeah, it would certainly colorize the operators differently than non-operators.
Yeah,
Within a
that helped
struct.
a lot. That did. You're right. They're kind of a cat-like typing, jumble on the keyboard looking things. I don't know. I burned a week at it, and then kind of like this, like for doing what we're doing here with Vec, it works out really nicely. Other than the whole, oh my God, it's a pile of jumbled characters. Yeah, that's a horrific looking variable.
Yeah, it's only the ones where you have arguments on the left side of the equal sign that I look at and go, I don't know how I feel about that.
Okay.
The rest of them seem totally reasonable.
Okay.
So like in Go, I kind of like their syntax of when I'm appending to an array, I say array name equals append of array name, comma, element.
Write me an example.
Let me
So
go
I
to the
gave you a
bottom.
plus equals as one example of a use case, but I could have a push as a version. I mean, I use push all the time because I'm often doing stacky things. So I want push and pop. And I literally have, I rename the damn get last element as pop, or add a new element as push.
So if I do something at the bottom that basically, if I have a dot append v, now I need to have different syntax if I'm doing a mutatey kind of thing versus if I'm doing a immutable a dot append returns a new thing that's got the value in it.
The array list is mutable on purpose. It's efficiency hack. So append mutates the insides of A, and you don't have to return it. I frequently will have append return one of A or V for what I call flow coding, for just flowing into the next statement, but that's not necessary. Yeah, vec.append of an element. Yep, there's a use. That's, in my opinion, that's a verbose way to say plus equals, but it has a function syntax, so you know you're getting a function call. And elements with an E if you're in America. I don't know where yeah.
So if the
And
second one is the standard way in your language that you do append,
the second way is not the standard way.
then I can either do a immutable collection that returns a new immutable collection
Right.
with one more thing in it,
Right.
or I can mutate it.
Yeah.
And I can use the same API for both mutable things and immutable things.
Oh, you could certainly have both plus equals and append. I don't care. And the plus equals and append they're just function calls under the hood. They can work for both immutable vectors that clone or not. I didn't report what you return with the plus equals. Right now I have it set returning E because that's the last expression evaluated. It could return the vec itself, and that would let you go to have the same API for immutables. I typically find it's actually more convenient to have the array because when I shove the element in, it's not 50-50 that I want the element next or I want the array next. But if I wanted to just return the vec as a standard return, I'd do this for plus equals. Now it's returning the dot, which is which is the vec. And that's the same API for doing update. I guess I have to do the same thing for colon equals.
Yeah, I would be tempted to make that the convention because it makes it easier to have structural sharing immutable things in the same space as arrays.
It's not a simple topic. We had to redesign ours 4 times because of this very topic.
What'd you end up with? What did you fail on, and what did you end up with?
Well, it's all about complexity trade-offs for the person using it, right? But array is such a special case. So we ended up with a four-way mutability with constant, persistent, fixed, and mutable. Yeah. So Java's arrays are fixed, meaning they're C arrays in the sense of you do an array in C, and that's what Java arrays are. but array list is what we call mutable. Meaning it grows, it shrinks, whatever.
Okay, grows and shrinks, not just the contents. Like the thing Java was missing is the contents of the array could be made
Right.
immutable at some point.
And then we have persistent, which is where a persistent data structure is one that like closure. Every time you do a mutating operation, it doesn't give you any visible mutation on the reference you hand it. Instead, it gives you back a new reference.
Right.
And that's what Aaron is talking about. And then we have constant, which is actually immutable. So it's basically persistent plus immutable.
Okay. Yeah, I have the notion that things are mutable for a while, and then you can throw a flag, and then they're immutable thereafter. And
Yes,
I haven't.
that's exactly the way we did objects.
Okay.
All objects have exactly that. Yep.
Okay. And then I myself find mutable arrays to be highly useful, highly performant, and you know they're my common thing.
Yep.
So I want to have them to be convenient and do what I want them to do, which is typically in the case that Aaron's talking about is return E, the element, because I'm going to do something else with it.
Yep.
This is what I normally find myself doing without the returning to this, it's returning E. When I do immutable arrays, which is very rare, I typically take a much smaller API and I very narrowly target, like immutable arrays are being used in places where, as opposed to arrays that are mutable for time and fixed thereafter, immutable arrays, mutable from the start, and I'm making additions to them by appending and copying new, or I'm mutating them by actually copying and updating in place, or whatever, however it's done. That I find to be extremely rare for my use cases, and I claim I have pretty broad use cases here, and highly imperformant except in very specialized circumstances. So I would say no, I'd make that one the special case, and you need a different syntax, and you use it in different places. It's very much more limited use cases. What are you doing with your last line? Somebody's doing some of the last line. I'm trying to figure out what they're trying to accomplish. A lot of cloning going on there. Yeah, as underscore as I used dot for the this pointer. Underscore is my other option for the bare underscore is the other option for the this pointer.
Right. I was wondering what happens if you return a tuple, but you only care about one of them? Can you do an unpacking trick with what comes back from the array append?
Yeah. Well, okay. So return a tuple and unpack. And you're saying I want them both back. I could, except I usually follow what I do with the element that comes back from the append is a one-liner, and it's a one character. It's a return the value. It's like,
yeah, that's going to make chaining less happy.
Right, it's chaining. I'm chaining.
You're going to end up with .1 and .0 a lot of places.
It's like kind of ugly looking. I would rather just say, I have a vec here. Somewhere else in the world, somebody else has an immutable vec with a slightly different API that has a much narrower use case, but it has a use case. It's just not the most common one. So,
and to be fair, my general argument on this topic is that the read side of the array is the most important API to maintain across these various things. So I'm kind of agreeing with you, Cliff, on this. Even though we ended up with the same API for persistent versus non-persistent implementations on the right side, the read side is the one where you really benefit as a developer from having the same, being able to pass a mutable or an immutable to the same place and have it treated, have it be able to go to the same slot.
I have like I said, I have the notion of I have frozen or made immutable as opposed to persistent.
Yep.
Okay. And I can pass immutable freely also. Okay, fine, but not persistent.
I tend to side with Rich Hickey on that one. I tend to think that the persistent data structure should be the defaults, both associative array and
well,
vector.
It makes sense in a functional language, but it doesn't make sense in, say, Java. So again, it's a brilliant idea if it fits with the language. If you try to jam it into a language that's focused on performance, it's going to kill you.
I claim there's huge performance differences in how they actually behave in practice, counting everyone's possible optimizations they've ever accomplished and all that kind of shit. The typical story I see is that if you have persistent arrays, you're slower by 2x to 10x. Like for whatever other reasons are going around, it's dramatically slower. And plenty of things I do, that's too much.
I'm not clear about Aaron's last comment. Are you asking about destructuring return values?
Yeah, I intend to do the destructuring return values that Aaron shows, probably with that exact syntax.
Yeah, that's the syntax we use.
So imagine any function returns multiple values. You put them in a tuple to return it. Where the receiver catches a tuple of multiple values. Well, he wants to desugar it right away. So he desugars with parens, tuple-like syntax, where you can sort of,
we tackled this one the same way that we tackled that Lvalue stuff I was talking about earlier, where the compiler allows you to write it as if you're using tuples, but if it understands the construct on the left and the right, it doesn't actually use a tuple. It doesn't create a tuple.
it doesn't so the optimizer has certain guarantees.
Right.
I promise you, under the following conditions, I will always get rid of the tuple.
So all invoke and all return. So all, call, invoke, return, all ops of those forms have both a 0 special case, a 1 special case, and a tuple special case. And then the general form is the n case. So you have 0, 1, n, and t. So for example, if you're calling a method, passing 3 parameters and getting a tuple back, it'll be a call nt. If you're calling it and passing 1 parameter and getting a void back, it's call 10. And so anyway, so it means that one instruction becomes 16, but hey, assembly is cheap, so.
Yeah, I think I have all calls take 1 argument, which is a tuple. And if I understand on the other side that you're not expecting a tuple, I'll desugar it for you. All returns return a value, but if you tuple it and then you put a tuple receiver on the other side, I promise you it'll unpack correctly without a temporary. But that'll be a language, an optimizer level guarantee that says for performance reasons, the same as a tuple constructor for a function arg call. The optimizer guarantees he'll unpack that tuple and never manifest it. Importing ABC from alphabet. Yeah, that's the right kind of thing. Wait, what is sys.import? Yes. Are you trying to get, you're trying to bring to the top level all arguments. This is like anonymous Python is doing Python things. Maybe, I haven't thought about injecting as is all the names, having a syntax that says, take all the names of whatever I'm returning, which has to be not a tuple, but a pile of named things, a named struct, and inject them without the struct layer in the current space. The current namespace. Right, so in the first version, I picked up ABC as the first 3 elements from the import. The last version, I pick up alphabet as whatever you got, which is possibly a tuple. And so everywhere I use it, I would have to say alphabet dot whatever 012 for tuples or dot field names. The middle one requires field names, not tuples. Won't work on a tuple. So you must be returning a struct, and it says, I'm guessing your syntax here or your semantic implication is all the field names that are mentioned in the struct that got returned are injected at the namespace 1 layer out without the struct on it.
Yeah, my suggestion with the unpack dot is unpack all. Stick all the names here in my namespace. It's essentially using.
Yeah, and star is the other version of the dot for doing that.
But it's an unfortunate mix. I know Python does this a lot, but it's an unfortunate mix between the left side and the right side. So the left side is static, the right side is dynamic. Which every time I see that, it's like, to me, it's like major code smell.
Right. I haven't sorted out.
Right, but I like the idea of unpacking is your using and unpacking is your import something from a library, but not everything from the library.
Yeah, no, I think that's fair. What you're doing is you're saying, when I want to import, like we're defining import here. What does import do? Okay, without adding any more semantics to the language or more syntax, import returns you a value. Now desure that value however you like.
Right. It either gives you a namespace or an index space, and you deal with that.
Yeah, right. And if it's an index space for tuple, you did tuple ABC and you pick out the parts you loved. And if it's a namespace, you could name the names directly also. You don't have that version showing there. That's ABC, where I had to pick the names from the right-hand side that I wanted to keep in the left-hand side. Not all of them. I would put an @ sign, I would put a structure for that. And the names have to match, and I'm just filling them in. It's @ with the curlies, and only valid fields in there are fields that match names that come out of import, and you only take the names that you get. So you list the names you're taking. Yeah, if you do it that version, then that says something like, I took the namespace I got on the right, and the C variable is a valid name, and I got a renaming of it on the left. I never like that. But maybe I should. I don't know. That's people saying, oh, the freaking sys.import author chose a really bad name here. I want to use a different name. And then when I go read the docs for the library I'm importing, it has this name, but all throughout the code over here, it has that name because the guy renamed it because he hated it. Well, he's going to rename it anyhow. So you're just making the renaming syntax cheaper. So fine.
Right. My SQL library has escape in it, and my HTML library has escape in it, and I'm doing both in this piece of code. So I want to import one of these escapes as SQL escape, and the other is HTML escape.
Yeah,
like,
that's fair. Yeah, that's fair.
It's convenient to rename stuff as part of import.
Yeah. Okay. Fine. Yeah, and so this requires basically no semantic meaning change from the user's point of view. It's all standard AA. The only thing being different here is how the names are getting mapped from the import into the struct on the left.
Now, as you discuss decels or, whatever, your operator syntax excludes the alpha num characters now. Is that
As an
the case?
operator, yes.
So
You can make a
if I
function
wanted,
call.
if I wanted a decel that says, select foo at
Right,
bar
right.
in the vector,
Right. You use
I
the @
can't
sign.
make an operator
Yeah, use the @ sign.
at.
You use the @ word, use the @ sign.
So, okay.
Yeah, there you go. No, don't use no characters.
That's an escape.
No
So
characters.
how do I escape to get back to, COBOL syntax?
No COBOL syntax, sorry. But I'll give you the @ sign as an alternate lookup. That would be this.
So the question is how to write link with the operators given.
I don't know.
LINQ, the C#.
Yeah, right. I heard that. So there's the alternate other than the choice of color for my operator characters. There's the syntax that we're looking at for the @ sign. Which blue is being used here? This one. And this should be all black now. Okay. Yeah, so there's an alternate @ sign. The infix with characters, I don't like because it's too easy. Because I could do it, but it seems like, well, it means underscore can't be used as a leading part of a standard normal variable name without you accidentally triggering it being an operator. And I like underscores, and a lot of folks use underscores as a leading character name of a variable anyhow. Like the underscore array as a private thing is not unique to AA. That's been around. I got that from somebody else. So I'm leery at the moment of allowing operators to have text in them, alpha text. So that says you're not going to get link. Not without a version that had all the SQL operators renamed to some operator syntax characters.
That's what scared me when I saw the underscore as private, is that now your namespace is locked into
Yeah, and-
um,
right.
non-alpha.
And that's me saying operators are going to be non-alpha. As a way for commonly folks to read the code to know what the hell is going on. You get some weirder things going on. The other thing happening there is that operator parsing is weird already. And I like to have I know you're a fucking operator before I get very far. I have to know you're an operator before I get very far, or I can't parse you.
So are we going to see people making second level indirection of operators in order to obtain operators?
Oh, I would love that. That would mean my language was wildly popular. People were hating on it and they were doing things to, work around the flaws in the language. And I'm just like, oh my God, I would love to be in that place.
Yeah.
That's a good problem to have.
That's a good problem to have.
That's Barn Stroustrup said the same thing.
There you go. I wouldn't necessarily agree with his choices either, but boy, he got a good problem.
So I wanted to point out, so what Haskell and Agda and a few other languages with extensible syntax do is they have a separate thing called the syntax declaration. And so that is what uses the underscores. And then when you actually use the operator and define a function with the operator, you don't use the underscores, you just use the syntax that you've already defined in the syntax declaration.
Right. I kind of screwed around with operators not having, like I did the curly brace thing around the operators, but then I couldn't define where the fields, the arguments got passed in the operator. And it seemed convenient and easy to let people fool around with how arguments got passed and where they got passed in the jumble of operator characters. So then the underscore syntax came around, and I'm currently liking it. I don't like the notion of a whole nother section of the parser syntax that's special for parsing. In particular, my parsing as it stands now is lexically scoped. Operators come and go by lexical scoping. So I can't have a pre-syntax spot that's lexically scoped in that sense.
Well, part of it is that you have to define things like associativity and precedence, and if you don't have, you can't really define those in the function declaration, I think. I mean,
Yeah, what is precedence order in this system?
So right now it's based on, I'm going to grab what Scala did and take it as the first character goes through the precedence order. And I'm happy to take arguments left and right. What did I end up doing here? I did something stupid here.
So if I do A plus B at C.
A plus B, yeah, A plus B at C.
A
right,
plus B is this built-in, at is some kind of override.
They get an operator precedence value from the, right now, I go back to the thing here. Let me go back to the thing here. Right now they get an operator precedence from the core operator they're overloading with, which gives them basically its first character that defines what the operator precedence is. And I'm happy to argue. It is the case that I have to have, for this lexical scoping of parsing syntax to work, I have to know the operator precedence when I begin into an expression of nested operator elements. So everyone who's an operator, even have different calls that overloads to different places, all such operators with the same syntax names have the same precedence. That is a requirement to parse, because I don't know yet who I'm dispatching to, so I can't tell you what the precedence level is unless I can guarantee it's the same based on only the text in my hands. So that means you're forced to pick an operator precedence, which is whatever the @sign precedence is. So I'll give you a pile of precedences and a pile of operators, and they'll have some list. That's what it's going to be. I'm kind of stuck with that.
Rather than just a straight left to right.
Well, that would say everyone's the same precedence. Which, I like my plus and multiplies have different precedents, but otherwise, all the funny guys, they could all be in the same precedence level. And then they'd all go left to right. But plus and multiply definitely have precedences that are not.
So how will an object specify itself as an operator in the chain of operator?
Okay, an object is not an operator. An object is a
below.
struct that has memory. An operator may have fields. The fields may have functions. Functions can have operators, can be
Okay, so
operators.
how is my link example below your vector incorrect?
So you
When
define
I'm trying to
link-
say dot is self.
Okay, so hang on. Yeah, so I won't allow dot as an operator, as a standalone operator right now. We could argue that I want to. So let me go parentize you and roboticize you a little bit.
Overriding dot is kind of scary.
Yeah, you're overriding dot, which is kind of scary. I know I have a couple things I don't let you override on purpose, like equals and colon equals and shit. Comma can't be overridden. There's a couple guys I don't let you override because I don't know how to parse it.
Well, the colon equals is overriding, right?
No. The
I mean, it's changing the
underscore
value.
colon equals underscore is overriding of a function called colon equals. Now that was only for the Lvalue case. Instead, I have the triple of underscore open bracket underscore close bracket colon equals da 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 da. A lot more syntax. That's a function overload. Yes. And colon equals is part of the function name. A leading equals and a leading colon equals is not part. And a leading colon introduces a type, can't be an operator overload. Leading equals is an assignment, can't be overloaded. Leading colon equals is assignment, can't be overloaded. Trailing colon equals fine. Trailing equals fine. Plus equals totally fine because it's trailing equals. That's okay. Leading equals cannot be overloaded. Okay, so in your example, you're overloading dot, which I don't know if I want to overload dot or not. Next, you define 3-argument function, takes an E, takes a self, takes an F. Is that what you intended?
More or less, that's what we'd be seeing if you disallow, it's symbol.
Okay, so we're not quite
subset.
there yet because the operator syntax says that the dot will be replaced with self as one of your arguments. You've defined a function of, now you define a function of 2 arguments. Do you mean 2-argument function or a 3-argument function?
Well, the dot is the placeholder for the dot.
Okay, so in the function I see for link right now, I'm going to go character by character.
Okay, so it is it's the first and last.
Okay, so now you have, yes, you have a 2-argument function and you have a 2-argument operator. If you want this pointer for link to be one of the arguments, you can use dot here. Otherwise, this is a static call in the link namespace that takes 2 unrelated operators. And I'll probably have to claim, I don't know how to get to the link namespace, so that's not allowed. And I'm going to have to deal with figuring that one out. I think that one's not allowed. I think you have to you must have a dot here because it means I'm in the link namespace. I look up in the link namespace for an operator that has this pointer. That's why I can be allowed to look up in the link namespace in the first place. I find, another dot operator. Okay, fine. I find a dot operator. And I call it with the trailing argument. Then the use for link here. So in this case, I make an L, which is a link. I construct a new link thing, and then I want to use it by saying L dot 5, and I'm saying the dot is an operator, and it returns whatever the function you had above returns. So it returns me a value. I don't know what you're going to call here. And now you have an operator with the dot. And I don't necessarily like using dot as an operator. I have dot for other things already. So I'd probably disallow dot. I have dot for other things. This is for field dereference. And I don't know if I can make an unambiguous grammar with dot here.
So the link definition you have right now, why is that not an arity error?
It has 2-argument operator, right? 2 underscores is 2 arguments.
Right.
It has 2 arguments, dot and F. So it's 2 arguments, operator, 2 arguments,
the
and
intent
function,
was
2
that
arguments right here.
Yeah,
The
why
intent
isn't
was
it
was
dot
a
first
totally
and
static
last?
monad.
Okay, I only
so-
one of you talk at a time. So Aaron, go first, but then Jim in a second.
Why does the first argument have to be named dot?
Because when I do the lookup, when I'm in the parser down here where I highlighted the L at AST equals L, I've just grabbed an L token. I looked it up. I now see a dot. what the hell do I do with the dot? An operator. So replace dot with an operator syntax.
So
for the moment that we know.
I'll take my turn now. What you're seeing is a new keyword being proposed. Link is a new keyword. E link F. That's basically the intent. That's what you would see from people who are restricted from alphanumerics in their operators.
Right. I understand what you're trying to accomplish by adding things. And what I'm stepping you through is what I can do that I know how to parse for is I make a link is a function which has a constructor. You just call it, you get a link object. Okay, that's the struct. Now I have a struct. I don't have a keyword. I don't have a magic new keyword. I have a struct called L. I want to take that struct and do struct-like things with it. Okay, now you're coming along, and after L, I see an @ sign. Well, that's all operator characters, so it's an operator. So I want to look up what the operators are valid at the current point in time. Well, I have a link thing on my left. I better look up and see if he knows how to do operators. So I'm going to do an operator overload lookup. Now, what really happens at this point is I don't know I have a link thing on the left. So I just look up the @ sign and say, this could be an operator. It better have the left-hand side be a namespace in it. But that'll be a type error in a minute. And I'll carry on parsing, claiming I'm now about to make an operator call of a 2-arg function. The left arg's done. I'm going to go parse the right arg. I'm going to build a function call to the @ sign and the guy on the left. That's how the parser, that's as far as the parser can get without any sort of typing knowledge. Later on, the typing system comes through and says, the thing on the left is a link. The function calls an @. I'll do a @ sign lookup in link. It's there. I can find it. It's done. And maybe, Aaron's question is maybe I don't need a dot here. I have to think my way through how I know I'm looking up @ in the namespace of link without it being the argument as well, right?
Context.
Like you could also have this operator syntax.
My instinct there is to name the 2 arguments left and right.
You can have this syntax as well. And the point of this syntax, now I have these 2 @ signs, and the parser comes along and says, I see an @, it's an operator, it's a 2-element argument, or a 2-argument operator. I'll parse a left and a right, and I'll make a function call to the left with the @ sign. Right? And maybe that's, and so you're correct. I don't actually have dot, doesn't have to be this. This is an implicit version where you actually get the thing I looked up at. Otherwise, I get an L. Yeah, I don't need this here at all. You're great. I don't think I need that. Oh, if I put a dot here, I'll allow you to use the namespace inside link. That's the reason you might want a dot here. You don't have to have a dot here. It imports the namespace. So in the vec example above, having a dot in the first argument position means in that body of that function, I'm going to take the this pointer for the namespace. And maybe again, I don't need it. I got here already. Maybe I don't need it. I have to think this one through.
Yeah, it seems to me like you could have just the left-right syntax, or you could have the dot left-right syntax.
Yeah, you're saying there's a third
you
argument.
can-
There's a left, there's a right, there's a this. I can't find, I won't ever call this function if I have another operator, because the first operator, there's no lookup in the namespace.
Right.
All right. So you can specialize E or F types at this point and start to build grammars.
Yeah, you could have and here let's see here. I assume you're talking about specializing here. Where I say there's a general purpose one, there's a special one that only takes links. And I demand a equivalence class separation of argument parameters in order to unambiguously know which one you're calling, but that happens in the case I just wrote. That's not too hard. And then the one down below where I have link in the body, I have to go sort it out myself. I think, Aaron, you've got a good point here. Somewhere in here I have an extra or a missing or there's something I don't need or I do need here. This pointer shows up in the lookup.
So what is my order of search? I first check to say in the namespace, is there a underscore at underscore that supports these 2 types? If there is not, then I'm going to look at the object on the left and say, hey, do you have an @ thing that I can call? And if that fails, then I look at the one on the right and say, do you have a thing that I can call?
Right, and here I've screwed up the how the operator lookup goes. I started out in the first case, or the top case I have on the page there, well, all operators are at the top level. I then moved on the inside because it looks like the vet case looks really cool. But then when the parser comes along, he doesn't know what type you are on the left-hand side, except in a very general way. And maybe that's all I need. He has to take the loosest possible type that you can have. Like he doesn't have any inference yet. So he doesn't know precision, but he might not know shit. He might know hardly anything at all.
Why the dot? Why the dot in the @ symbol here? This is assumed implicit in the body of the link queue. Where
does the operator appear? Yeah, so well, it's the difference between a static call and a non-static call. In the Java world, there's static and non-static. That this operator, that this value is passed in, hidden, and therefore I can expose the fields of this object internally visibly. Or it's a static call, and I cannot talk to the internal fields because I don't have a this object. So I want to say, you instead of saying the keyword static, to say no this, and you always get a this otherwise. So Java has it where you can choose to have a this or not. You say static for not the this, and you say nothing to get a this. I wanted to sort of clean it up a little bit and say, you put a dot in it, you got a this. You didn't put a dot in it, you don't get a this. You add an argument, the argument's called dot, that's a this, the shortcut name for this. So
Yeah.
I'm trying to claim that's the difference between a static call and a non-static call.
The dot, it will be hard to disambiguate. I understand what you're saying. It's as if we cut this operator and paste it inside somehow, and this operator will take the link queue as its first argument in order to operate in the fields.
And what I claim is for the current link as it's written right now, you have 3 arguments. One's the link operator. Whenever you would do the lookup and find this link operator in this scope, you have to have a link object around to do the lookup in, or you wouldn't find it, right? So this guy says, I need a dot, and I have 3 arguments. One of them's the link. There's another version, which looks like this, but it only works if the overload here is one that I can force an overload on and find you, but I don't like this one because I don't do the namespace first. Right, this one requires me to do a namespace inside the link, but then hey, it only takes a link on the left, so therefore it must be this guy, and it's the it's the hidden version of the first link I have at the top of the screen, and I don't know how to do that guy. So the one I just wrote, don't know how to do, so I'm going to unwind it.
The second will be take any link queue which complies, but this is the this link queue. This is the
this link queue, right? And F would be, they're called the right argument here. I'll rename
this
F.
is not different, in my opinion, of course. If you in Rust, this will be self because self.
Yeah, it'd be self, right. It's called this, or it's called self, right? Yeah.
Because they allow to define the operations outside of the class.
Right, and that's what I wrote up top.
The traits. The trait will be take this pointer.
I'm going to move you up to the other ats up top here, because that's another version, right, of the same. The goal of this was to say, here's how I can have the @sign operator, have an operator defined outside of a scope. If it's inside the scope, I have to do the lookup in the scope. I have to have a scope object to look up in. Therefore, the first argument is the this pointer, and therefore the dot is required as a this pointer. Or I skip the dot like Java does.
This self should know that is a link queue self, because in Rust you define it in the trait, because it has to know what self this means. It's not any self; it's the link queue self here.
Yeah, right. That's what I wrote. That's what I have above you already. Just replace the word left with self. It's all fine.
Yeah. Okay.
It's slightly different.
Yeah.
I mean, is self other actually slightly different, or is it just identical to left and right?
I would claim I need to have a equivalence class breakdown of the argument names or argument type space to unambiguously know which one to call, which can work in what you, with a bare other, you have cut the namespace into two portions. One where the left is a cell, left is a link, and the right's anything. And the other version is the 3/4 where the left and the right are anythings. So as soon as I have two arguments, I want to claim, and two choices, everybody and a subset of everybody, I have 4 quadrants. You took one quadrant out by yourself and other. I took the bottom half, or the bottom quadrant named bottom half, the bottom right quadrant. I took the bottom right quadrant. And that also, besides being an equivalence class, I can also break it down to a tree of equivalence classes. And I might demand the tree version. It's a little tighter constraint than just equivalence classes, but it's also easier to understand. Basically, I think Java does the same thing. It's the most refined type going left to right kind of thing. There's a rule involved for people doing this.
If we cut out this here, it has to have more context, or it has
Okay,
to
so
have.
as soon as you add the right as an int, I claim you have 3 types of excitement. You have the general, you have a link, and an unrelated int. And now I claim, too easy to be confused. I demand you start to fill in the other options.
Well, how would we create a singleton like nil that exists? There is only one, and call it link. And then, link is there for being used as a.
Well,
as a
nil is
signpost.
special in a lot of ways, and you can't make another nil sort of by definition. You can make a singleton
we-
object. Same as you in
Okay.
Java, you say new object. You got a singleton object, no one ever seen it before. It's unique across the entire JVM heap, blah, blah, blah. That's not what I'm not sure what you're asking for.
If we, go ahead.
Go ahead.
If you add the add operator here, and you don't enclose it in some kind of scope like a trait link here, this would qualify actually as an extension syntax. If the first is a self or something class, because it's not enclosed, this qualified as an extension.
Okay, yeah, whatever Russ calls it. I would say for me, when I do method resolution, I will look at all the various types for a method name. The method names _@_, and there has to be unique match, a unique most specific match. But I also want it to be sort of obviously unambiguous. So somebody's busily adding various kinds of ambiguous cases, right? And I would claim at some point I want to demand that you fill out the other options so I don't get confused. And there's another thing that says the versions of int, u8, and 7 are all monotonically sharper. And so I can claim there's a tree-like breakdown of the type.
Right. In this case, they are monotomically sharper. I would think you could unambiguously say, I'm going to pick the
Maybe this
smallest
one I can. I'm not certain I like it. It looks too dangerous, but maybe it's okay.
Scala uses the first type argument to disambiguate.
Yeah. Once you've done the first and you have 3 ties, what do you do with the second and third arguments?
Well,
see, there's another version that says I have a link on the right and an int on the left, which maybe is unambiguous, and then there's an int version.
I would say logically what falls out is 7 is sharper than uint 8 is sharper than int. I just feel squirmy.
Yeah, it feels squirmy, but maybe it's fine. This one might be fine.
But it feels like the most consistent thing to do.
Well, there's ambiguous, Julia goes hog wild here. There's unambiguous, and then there's what you can read. So what you haven't done here is look at what happens to the return. Suppose each of these ats return a different type. Then they go in a larger nested expression of at expressions, each one producing a different return type, so it induces a different exit. And then you get this complicated tree. I think Cameron went down this path at one point. Get this complicated tree of possibilities of, I could take this overload plus this and this and this, or I could take that. And the learning I got from Cameron was, don't do that. Be unambiguous layer by layer. So unambiguous.
You don't want auto conversions to to automatically explode that complexity.
You're saying no auto conversions. Yeah.
This is DSL 101. Creating these syntaxes, chaining by type, and and thereafter you get, you know, autocomplete in your IntelliJ.
No, the problem here is you have to have it be easy and obvious to read and know what it means. And you can arrange for situations where you have an exponential set of choices, of which it happens to be the case that there's only one in the end, but you have to explore this large namespace. And you can arrange it that the parser to disambiguate explores a 2 to the n namespace and then finds there's exactly one in the end. But he has to explore the entirety of the namespace before he can tell you what the answer is. And the thing that I don't want to do is I don't want that to happen, right? So the thing I want to do is say, if I look just at this one function call, I can disambiguate it. Now it returns a type that goes into the next function call, which I can look at it alone and disambiguate it and repeat ad nauseum. So it's only a one-step disambiguation, step by step by step. Not, I look at these 5 in a row in conjunction all together, and there's one choice out of a 2 to the 32 choices. So that's the sort of the danger and the rule I had of the arguments have to be monotonically sharper and probably going left to right monotonically sharper, and that's the lookup rule. As soon as you add the F64, you're now ambiguous with 7 and U into 8, and I'll blow up and say you're ambiguous. So I would comment out the F64 line, but leave it in place for comments for us for annotations. I'm going to comment it out. This is an error because it's ambiguous.
Yeah, I think you're fine with the first 3 as soon as you drop in the 4th.
Yeah, as soon as you drop the 4.
Now does not compile.
And you're actually fine with the first 4s, whatever, all 5, because they're all monotonically distinct or sharper. The general right case handles everybody else. The link on the right is different from an int on the right. And then we're still left with, do I need a dot in the namespace if I bury an operator inside? I think I still need a dot because I won't do the lookup inside the guy on the left properly here. I have to think about that one still. When I do namespace resolution, I'm going to basically, yes, I'm going to basically take the operator. So it says link equals blah, 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 under, at, under, inside there. I am essentially going to, at parse time, lift it to the link at the top, or one of the links at the top. That's the semantic equivalent. You wrote it inside link. It's going to be exactly equal to a top guy, a top exposed guy, where the left-hand side is a link type. And with a little added caveat that the body can automatically refer to the left-hand side link's contents.
So in the
Now
body
I'm
of link, what
unclear.
happens if I put colon equals?
Where? Write the colon equals. Oh, okay. So yeah, so that's an open question I'm sorting out with. The nature of function overloads, because they are distinct, I'm allowing you to do a final operator, a final variable assignment, overriding @ sign over and over and over again 5 times in a row there. And I should demand you use colon equals. But instead I say, because the arguments are completely disambiguatable, I will allow you to multiply assign, and I will do the lookup at someone in typing time and come up with the correct version, basically extended parse time, come up with the correct call you're making. So it's semantically as if you just
Right, but I would argue that if I put colon equals there and say this is redefinable, I should be able to take a instance of this object and change the definition of that override.
Oh, I see. Yeah, no, maybe you're right. I'll demand you don't. Right now, by the way, the theory is that if you do the standard final assignment, I won't actually put a field in any link objects in that struct there. That's called, @ sign. The field won't appear there. It will appear in the class object. If you make it mutable, it has to appear in the object. I have to do a runtime lookup for the value.
Right. I would say the moment you put that colon there, you've actually moved the function from the class to the instance.
Okay,
And now
let's call that a different problem to sort another discussion. Not that I don't want to discuss it. It's an interesting discussion, but it's a different problem. It's literally, when do I allow a function to be moved to a class, secretly moved to a class behind your back? And it's not just functions. It's any field, any final field can be moved to a class. And then when do I say, no, it has to be present? And that's, you know, is there a semantic meaning change? Can you tell the difference? Is it hidden behind your back? I won't tell you what I'm doing. I'm just going to make it work. So there has to be a fixed semantics. So out of all this discussion, what I came around to for me here is the dot is necessary if it's inside inside of a struct, because I'm going to export the operator out. For the parser's sake, I have to export the operator to the top level with a known sharp type. So the operator can be witnessed to be the same precedence ordering, the same arity, the same this and that, where the parser has no clue. He has to parse, but he has no clue what the type is and what the argument count is and all that kind of stuff. He has to know all that ahead of time while he's parsing. Lazy arguments are ampersand only arguments that pre-Lvalue. All these things have to be known at parse time. So they all have to be identical across all of instances of the under operator. And therefore I can effectively hoist it to the top level, and then I'll disambiguate it later when I'm done parsing. And I begin doing type analysis, I'll figure out which one you're calling. And one of your options will be the version where you have link as a left operator, and it will be because it is in fact the left object, and therefore it's the dot operator. So there is a tight correlation there, and maybe we can tease it apart yet, but right now.
That's not a general rule that every single function that lives inside of an object has to have a dot.
No, if you don't
if you have the dot, then you are an instance method, and if you don't have the dot, then you're a class method.
Yeah, right. Basically, this is operators have this special problem. Everyone else is a function call, and it's a standard function call syntax, and I don't have this problem. Operators, I have to know shit like, do I lazy the right hand side argument? Do I Lvalue the right hand side argument? Do I what's the precedence order? What do I reorder the shuffle the argument precedences around? All these things have to be known at parse time, and therefore they have to be the same across everybody, and therefore you're forced to have that left argument be, you know, a particular argument. In theory, it says like you could have one that didn't have it, but I don't know, you'd have to trouble calling it out. Oh no, you could call it out with the non-operator call syntax. The non-operator call syntax. You could have a link that didn't have a dot there, and you would say L, and I'm going to say dot the field as a full field, and now it's a function call, and I put my right argument in here. I mean, that's not what you're looking for, but and then I could have anything I wanted here. I could have a left and a right with a static call left and right, but that's a funny call syntax on an operator. That totally works, but it's not being used as an operator. It's just being used as a field name. So for you know, the funny thing I do here is if you have a field that is typed as a function, it has only operators and underscores, operator characters and underscores, you became an operator. And then there's another version of a call that gets made that's allowed to be made where I drop the underscores, replace them with expressions in operator syntax. Yeah, that could have a version where L is another. No, L is not available there. L is not available because you said L dot. It just did a look. It took a struct, took a field from a struct called under, gave you that contents of that field. The L is not part of the expression anymore. Now you have a function, you have a call syntax afterwards, L is not available. So this is what that's equivalent to, but that's what you wrote. This, where the L, that's not possible here. You have to pass it in, and you can have a 3-argument version that has an L like this. And the fact that under has 3 args, but only 2 underscores, I would probably call you an error, or I would say you're not an operator. Because you have you have a mismatched argument count and underscore count. So I don't know, one of those is an error, it probably should be an error. So I'd say no. If you had a 3rd argument, the 3rd underscore, you know, you could have a L, but you see where I'm coming from or where I'm getting at here?
Yeah, the difference there is if I use L dot, I'm looking up the function inside L.
You're looking up the function, yeah. And now you've looked up the function, having looked it up, you execute it. You call, make a function call. Yeah.
Except that when I actually call it,
No,
it's going to have the pointer to L inside the dot, is there not?
Yeah, this is a version where left becomes the dot value.
What would be the purpose of the dot here? What would help?
Well, the purpose of the dot was simply a short for the word this. In most
Okay.
in contexts where you're calling it as an operator, it's always the left-hand side guy. It's the this guy.
But the purpose of the dot here is to call this here inside the body of the function. or not?
And the second purpose is to say, I'm going to now automatically give you the field contents. Yeah, the namespace lifting. Yes.
Mhm. Yeah.
So it does two things. One is it's an argument that had to get passed in a 2-argument function, and it's a short form for lift things on the right. If you put a name there like left, I won't lift things on the right, but you could say left.array or left.linky fields, whatever linky's doing. And here you're saying m is a variable that picks up an operator, but not as an operator syntax. Now it's a function. @ just takes 2 arguments. You're busy passing 3 to it. That's not allowed. Stop passing 3 arguments to a 2-argument function. And where it says m of open paren l comma left comma right, you don't get to do that. Because
Why? M is a 3-argument function.
no, at's a 2-argument function. I'm not handing, currently I'm not giving a third hidden argument. The way Java gives you an extra hidden,
I see.
I'm not giving you the hidden extra argument. Yeah, you can do it that way. And now that's just a function call like I did 2 rows up.
Okay.
And it's not
So I
L dot-
totally can pull the function out of the class and then just call it by passing in whatever that function can take.
Yeah, you can pull it out of the class, just what you did. That's okay.
And the first argument will be the thing that's referred to by dot.
Yeah,
Okay.
hang on. Okay, yes, this is fine.
This does beg the question, why does dot need to be special syntax rather than just using the word this or self or whatever? as that first
Because,
argument?
okay, so it's special syntax because, this is what TDOR pointed out, because I use it as a keyword to inflate, to lift the fields of the link object to the namespace inside the function. So let me write another version of this guy with the this operator. I'll show you what's going on here. So instead of dot, I use this. But now link has some other fields called array, which have been set to blah, blah, blah. And it's, it's a little array, thank you, Google. Fine. Okay, so somewhere in here, I can say, in one of them, I have to say this dot array, and the other guy, I can just say array. Right? In order to just say array, I have to be inside of a struct. What struct am I in? I'm in the dot struct. As opposed to being in only the one instance I would get if I were doing up here. That's the namespace question that's going around here. I'm doing a namespace hack on you. Yeah, what are you doing with this dot equals this? I don't know, but. Oh, you're trying to rename dot.
Putting the dot there in the header is the equivalent of pulling in a this and then doing the tuple unpacking of the this and say, dump everything in this namespace into my namespace.
Oh, yeah, if you do tuple unpacking as paren. Yeah, maybe. Yeah.
I mean, okay, if you want to use the tuple unpacking
Well, the
syntax.
tuple unpacking for structs is because that's what I'm doing elsewhere with structs. I mean, that's a structy thing.
So like, fine. So it's the same as doing, bringing it in as a this and then doing the tuple unpacking.
Yeah.
Except it's just one thing that says bring this in and tuple unpack it.
Yeah. That's not a bad, and then you can use array here. And let's go add the third guy because this is the which one you're just, so the top one, we put the bottom one here. I don't know which way we're gonna put the order in. What did I do? I just shrink. I know, get V. I'm grabbing Emacs keys here. Yeah, they all do the same thing. The last guy is the default syntax. If you don't have a custom special syntax, all functions don't have, there is no instance of in a function land for me. Functions are just functions. They have no special instance of functions. So I want to make a specially one where I have this as the first argument, but then I want to export all the fields. So I don't have to say this dot, this dot, this dot, this dot. Okay, that's the middle one. Oh, I can make it even shorter and put a dot there.
But now this is equivalent to a class, yes?
That's the
can
goal,
create
is to
new-
be link as a class object. Yes, it's not equivalent, but it's the goal is to make it behave so much like a class that you like to think of it as a class when you're coding.
Yeah,
But it's
but
just
if
a
you
struct.
make a new instance, doesn't mean that it has an implicit this pointer at each creation.
Yeah, it
But,
does.
we
That's the guy you got there. When you said L equals link, you made a new struct of type link or
Yeah,
whatever, that
in,
struct type.
in Java, why would you want to have a dot? Because when you create a new instance of the class, you have this pointer immediately, and all the functions here can refer to
Okay,
the methods inside the class.
so Java has instance methods, static methods.
Yeah, the static is in one per class, per object. Or
Static methods don't have a this, instance methods do.
yeah,
So my distinction between static methods and instance methods, the way I syntactically tell them apart, is I put that dot there. Now you're an
okay.
instance.
So this is equivalent to a static.
No,
It's something.
no, their only
Hmm.
functions are only static calls. Oh, I only have static calls, but I'm going to fake it till I make it, right? By saying the dot is syntactic sugar for explode out all the names of the left-hand argument, which has to be of type some struct that you're buried inside of, explode all those fields out.
Okay, so it will allow you to use the fields inside the body.
Yeah, the dot says explode them out as names, as if I did the middle of those ats where I do a namespace unpack. That's an as if I namespace unpacked you without actually doing the effort of namespace unpacking.
Okay.
What the goal behind that one is I don't have two different kinds of functions. I have one function only, and that's the standard lambda calculus function. It is passed arguments. There's a little syntactic sugar to make it a little sweeter to eat when you're doing object-oriented things, but it's otherwise just a standard lambda calculus function. And that means I can do standard lambda calculus things with it, which is the whole point of that. You know, in JavaScript, there is totally that same notion, except they have a special binding syntax where they take the this pointer and bind it. Basically they allow you to curry. And then they say it's a curried function. Oh, you got the this pointer. Okay, we'll curry away the this argument. Now the function is complete, but they call it bind, it has special syntax. So I'll kind of screw around. As soon as I get currying in here, and I probably will have currying in here, you can do the same damn game, but it will be currying. It won't be special syntax for anything. I mean, we are like 12:30, folks. It's 2.5 hours into this. It's like good. We should do syntax at every meeting. God, people get hot and excited and goes on and on.
So we do the same thing, Cliff, except we call it mbind, which takes a method which is not callable. It's invocable, but mbind turns it into a function which is callable. But there's actually something that occurs in that binding, which is based on what you're calling left type, the left-hand side. The bind actually settles, forms, whatever you want to call it, the call chain for the function. So that because there's in a method, there's a super.
Right.
Not a reference to an object super, but a reference to a next function to call super. So
that's sort of different notion then. I don't know what you're talking about. Is the Java super or related to the Java super? For a method, Java has supers for instance.
So think of super as being, in Java sense, it's kind of a method handle to the invoke special of the supers classes method.
Yeah, right.
So it's a pre-bound invoke special.
Oh, I see what you're saying. So you're saying that the act of doing the mbind, you then bind the super.
Well, it's as if that happens. We actually pre-calculate all that right in what we call a type info. But yeah, so we have an array of function pointers, and then as you call down through them, that array actually has to get passed because the chain can differ from type to type because of mix-ins. traits, if you will.
Oh, you have mixins mess with your
Yeah.
super class notion. Yeah, I haven't sorted out whether I love mixins or not.
Oh, I love them, but they're not simple.
Right. Yeah, that's the question. Right.
So, but
Okay,
yeah, it's a minor hit.
so if I say my method equals my object dot this override,
Uh-huh.
do I lose the binding to the instance?
There was never a binding to instance to be lost.
So like on my second method call here, this would be
Uh-huh.
method of object comma right, or just method of right? And method knows that it was a method on object.
It would be the object dot under right is not legal syntax as it stands right now, because object dot under is a field lookup. Having completed a field lookup, you have a value, and object is not that value yet, what it was in the field. Now you have a field which is function typed. It's being passed one argument. It's a 2-argument function. So the middle of your 3 calls is not correct. The right-hand side as an operator is correct. The left-hand side as a bare function is correct. The middle guy, yes. That gives you the semantic equivalent. But like I said, there was never any binding to this. So you could pass object in, but you could pass anything you want in. And you've named the function by doing object under lookup, and you're calling it with 2 arguments, whatever the hell they are. They don't have to be related to object. It could be object 2.
But if I just say object dot method open parentheses arg,
Object dot method is a field lookup. You said method, but it's a field. So it's object dot field. There is no object dot method. There's object dot field lookup. Now you have a field looked up. It gave you a method back. It gave you a function, a standard everyday lambda calculus function. Now you're calling it with some args. 2 separate steps. There is no crossing between them.
so if I do something like vec dot append,
That did a lookup of a field in vec called the append field, and gave you whatever append is as a field value, which is probably a function.
so I can't be vec dot append L.
No,
I have to say vec dot append
vec, which is not the syntax you want to have. I
vec
understand.
L.
Yeah, I understand it's not the syntax you're looking for.
Okay,
And that's why you would go to an operator where I will pass in the vec as the first function, first value. And that's because operators are semantically lifted outside of vec, and they're known to not have any overloads to anyone else. So I'm happy to have a discussion that says, I hate this syntax, and the dot version takes the left-hand side and only is valid if you have a vec.append and the dot takes the left. So my current theory, the theory that I'm claiming the least special cases in the universe, is vec.append is a field lookup, period, end of statement. There is a second version of this which says vec.append, where the contents of append is a field that is a function that has a dot as its first value. I will go ahead and take the left of the dot append and pass it along. That's what Java does. And I can be talked into that one, but it's definitely a more complicated syntax or a more complicated function call.
So we actually support that. In addition to method calls, we support something like what you're saying, and we actually call it stripping or something, right?
Oh, brutal.
What is it? Stripping? Yeah, it's something like that.
You allow the syntax and you give it an evil name.
Huh? Bjorning. We call it bjorning.
Excellent. Bjorning. Yes.
So, but it's handy for functions when you can use context. So.
Yeah. No, I get it. I was thinking I didn't need it, and I went back and forth, and then I stared at theory for a long time, where I forgot all my AA syntax questions, and now I come back around to it, and I know I visited this before in my head and gone back and forth, around and around. So I'm not settled, Aaron. I might yet say, yeah, there's the append vec where we went to the high level. That's like the Python version. I like the Java vec.append of L. I do like it. So maybe I'll do something there, but that does mean I have another kind of lookup, special lookup that says, do the lookup once, and then, oh, it's a function in the body and it has a dot. Okay, now pass the argument along.
So we have a comment.
yeah, I kind of like, oh, sorry.
I was gonna say, we have a comment. was Bjarne transformed from x dot lowercase x dot f to capital X dot f of lowercase x. So that's the
I don't want to. All right, I am starving.
Yeah,
I have an appointment coming up in a little while, so I want to call it here at 2.5 hours. This has been freaking awesome. I got, whacked on my head. I don't have the right syntax. I got whacked on the head for other things. I've decided I believe in some of the things I'm doing, and I'm not so certain about other things. So there is grist for the mill as usual. Oh, there it is. Code template block for copy. Private transient Boolean M under F Bjarne. No, I don't have transient yet either. Oh God.
oh no, that's Java code actually. That's not ecstasy.
Well, no, I know. Oh no, I don't know that. Okay, fine. Yeah, I recognize the and in H2O land, I totally overloaded. I took transient to mean don't pass this field back and forth between clusters when I did my auto serialization, just like it was supposed to.
Yep.
And very convenient and very confusing to many different people. They were like, what the hell? Hey, what? No, yes. Great. No, it was back and forth. Okay. Awesome. Well, this has been a ton of fun. Boy, I'm happy to do this again next week, but I got shit I gotta go do.
Okay.
Till we meet again.
Yep. Bye.
All right. Bye-bye.